Hey folks, so today we're going to take some notes based on the work that you were doing yesterday with area and perimeter and things like that. So in your workbooks on page 172, you have the formulas that you need. So the formulas for area and perimeter. And a couple of things that I'd like to show you. One is that for triangles, there are 3 different formulas for area. There's the formula that we all know, base times height over 2. There's another formula, and this formula is especially useful if we know 2 sides and the angle in between them. Okay, so for example, if we knew A and B, we could find the area by doing side A times side B times the sine of C. Remember last year when you were doing sine law, right? Sine, it's a function, it's a button on your calculator. And so you would do the length of side A times the length of side B times sine of angle C and divide all of that by 2. Or finally, we could do the area of a triangle using the square root of s times s minus a times s minus b times s minus c, just remembering s is half of the perimeter. So we would have to be able to find the perimeter and then divide that. And we choose these formulas based on what we know about the triangles. Finally, for like pentagons, hexagons, right, all of those, we have something called the apothem. It's kind of like the radius of a circle, but the only difference is that it has to meet a side at a right angle. And today we aren't going to look at how to find an apothem, but if we have it, we can find the area. So let's take some notes. Okay. So on page 173, there are some examples that we'll do together, and then you'll come back and work on these practice questions once we're done with all of the notes. So here we go. This question says, find the area and perimeter of the following shapes. So the first shape we have is a trapezoid, right? So the area of a trapezoid, base 1 plus base 2, that whole thing, times our height, and then divided by 2. So in this case, base 1, 12, and base 2, 7, times our height, 4, divided by 2. So 12 plus 7 is 19. So we have 19 times 4 over 2. And if we calculate that, 19 times 4 divided by 2, we can do that all in one step. The area is 38. We always need our units, so we're looking at centimeters squared. And if that's our area, our perimeter, we just add up so there's our area. Our perimeter, we just add up all of the outside sides, right? We don't have to worry about the height because our perimeter's like we're walking around the outside. So perimeter is 5 plus 7 plus 4.47 plus 12. So 5 plus 7 plus 4.47 plus 12 is 28.47. Units still in centimeters. So that's all we need for our trapezoid. We found the area, we found the perimeter. Let's take a look at the circle. We need the area and the perimeter, which for a circle is called the circumference. So area is pi r squared. Remember, r is our radius, and we have a radius of 3. Pi times 3 squared. And you could do 3 squared first, or you could just type it in a calculator like this. Just a reminder from yesterday, I really do prefer you use your pi button on your calculator rather than rounding it to 3.14. So pi times 3 squared is 28.27. Our units, we're talking about area, so it's meters squared. Circumference of a circle, 2 pi r. So our circumference is 2 times pi times 3, which is 18.85 meters. Now we get to the triangle. And I know the first inclination is often to do base times height over 2, but in this case we don't have a height, and it's going to be a little trickier to find the height. So what we could do is look at the other formulas. And one of the formulas we have for an area of a circle, right, is if we know all 3 sides. We do need the perimeter for this one, right? Or at least we need the semi-perimeter for that equation. So let's find the perimeter first. All right, the perimeter of this triangle, 5 plus 5 plus 8. So our perimeter is 18 meters. If our perimeter is 18 meters, then S, our semi-perimeter, is 18 divided by 2, which is 9. And now we can use this in our formula for area. Area equals, I'll put the square root in after, S times S minus A times S minus B times S minus C, and we'll take the square root of this whole thing. So S is 9. And it doesn't matter which is A and which is B and which is C. So I'm going to call this A and B and C. So we have S and then S minus A, so 9 minus 5. And S minus B, it's another 9 minus 5. And S minus C, 9 minus 8. And if you wanted to do that subtraction in your head, totally okay. I'm just writing it out so you can see all of the steps. 9 minus 5 is 4. Another 9 minus 5, also 4. 9 minus 8 is 1. And 9 times 4 times 4 is 144. And if we take the square root of 144, we get area equals 12 meters squared. Okay. So basically just find the formula that you need, plug in what you know, solve for area or perimeter. Okay. We're going to come back at the end of class. You're going to do questions on page 173. But before we do that, let's take a couple more notes. Okay. One of the other things we talked about briefly yesterday was the Pythagorean theorem, which you've seen before, but just as a reminder, let's do 2 examples. So for the Pythagorean theorem, it really does matter which side we label is C. Okay, so Pythagorean theorem, we have to have a right angle triangle, right? And remember these little boxes in the corner here, right? This means that it's a right angle, it's a 90-degree angle. The side that's across from it, so the side that doesn't touch it, it's our longest side of the triangle, that always has to be side C. Once we have C sorted out, it doesn't matter which one is A and which one is B. Okay. So our Pythagorean theorem, A squared plus B squared equals C squared. Oh, I don't know why my A jumped, but let's see if we can get it back. Okay, so A squared is 12 squared. I seem to have lost my pen. Let's see. There we go. 12 squared plus B squared, 20 squared, equals C squared. Now, order of operations tells us we have to do our squareds first. So 12 squared, 144. 20 squared, 400. C squared, well, there's nothing we can do with it, so we'll just leave it. 144 plus 400 is 544. And now to get C instead of C squared, we'll take the square root of both sides. So the square root of 544 is 23.32. And we don't have any units written here, so I'm just going to write U for units. So we found C, we found that missing side. Let's look at our next example. Here's our right angle. C, side C, can't touch our right angle. It has to be across from it. So that has to be C. Doesn't matter which the others are, A or B. Right? So just as a reminder, A squared plus B squared equals C squared. Well, this time we know A, so A squared, 16 squared. We don't know B, but we do know C. So let's take a look. 16 squared is 256. We still have our B squared equals 25 squared, which is 625. Now we need to do a little bit of algebra to get B all by itself. First thing, let's subtract 256 from both sides. So 625 minus 256 leaves us 369. Right, so we know B squared is 369. So if we take the square root of both sides, we get that B equals 19.21. We don't have any units, right? We don't know if it's inches or centimeters or kilometers. So we'll just use a U for units. Okay, so there's a quick reminder on the Pythagorean theorem. Again, here are some practice questions. We'll come back. We're going to skip a couple of pages. We'll come back to them in the next couple of days. But for right now, let's skip them. So we're going to skip page 175, 176, 177, 178. We're going to also skip page 179 and 180. And here we go. Let's take some notes on page 181. We were doing some of this yesterday too, right? This was missing measures. So this was maybe we knew the perimeter or we knew the area, and we needed to find something else out about our shape. So what we need to do that, like we need to pick the right formula. Are we talking about area or perimeter? And sometimes we have to think about what we know and what we want as well. Like think about the area of a triangle. We might pick, each of those three different formulas based on what we know. We're going to plug in what we know, and we're going to use algebra to solve for the missing variable. So let's take a look. A triangle has an area of 12 centimeters, right? So we have an area of 12. We know that we have a base of 2, and we want to find the height. So to do that, let's use our standard area of a triangle formula, because we know the base, we want to find the height, right? Which leads us to this formula. These are the variables that we're interested in. Area is 12. All right, that's from here. That's from our question. Base is 2. Height we don't know. Divided by 2. So if we do a little bit of cross multiplication, right? 12 times 2 equals 1 times 2 times h. Well, 1 times anything is just that thing, so we don't have to write 1 times 2 times h. We can just write 2 times h. 12 times 2, 24. And then we'll divide both sides by 2 to get h all by itself. And let's finish this off. Let's write a nice concluding sentence. The height of the triangle is 12. Our units are centimeters. Right? So we knew area this time, we knew base, and we were trying to find height. So we're just working backwards a little bit. Right? It's a little bit faster to use algebra than to guess and check. This one you probably could have gotten away with guess and check, but some of the other ones it's going to be much more difficult. So let's take a look at this one. What's the height of the trapezoid below? Well, we know the area, so we know that we're going to start with the area formula, which is base 1 plus base 2 times height divided by 2, which means, let's plug in what we know. We know the area is 92. One of the bases is 14, plus the other base, 9, times height, we don't know it, divided by 2. We have another fraction, so we'll do some cross multiplication again. 92 times 2. 1 times 14 plus 9 times each. Let's simplify this a little bit. 92 times 2 is 184. 14 plus 9 is 23. And finally, we can solve for h by dividing both sides by 23. So 184 divided by 23 is 8. So if we wanted to write a concluding sentence, the height of the trapezoid is 8 centimeters. All right, so missing measures. Let's do just a little bit more. You'll come back, you'll do these questions. But let's talk about equivalent figures too. And this middle example, it's crossed off. Don't cross it off in your workbook. We are going to come back to it, but we're going to come back to it once we've talked about finding the apophthegm. So not today. So there are a couple of questions that we might get around equivalent figures. Remember yesterday we said shapes are considered equivalent if they have the same area. And so this first question says, show that the following figures are equivalent. Well, to show that they're equivalent, all we have to do is show that their areas are the same. And I know that this doesn't say that it's a square, but it is. So let's force it into one. Let's write this other side as 7. So to show that they're equivalent, let's find the areas of both of them. The area of our trapezoid, base 1 plus base 2, times height, over 2. Base 1 and 2, 9 and 5. So it's 9 plus 5, times our height of 7, divided by 2. 9 plus 5 is 14, times 7 over 2. And we can put that all into our calculator at once. 14 times 7 divided by 2 is 49. Our units, centimeters, we're talking about area, so it's centimeters squared. If we look at the square, we can either say area is side squared, right? Or we can think about it as side times side. Either way, we get 7 times 7. So our area is 49. We're still talking about centimeters. We're still talking about area, so it's centimeters squared. So these figures are equivalent because they have the same area. So let's write a concluding statement. These figures are equivalent because, let's say they both have an area of 49 centimeters squared. Okay, always nice to have a concluding statement. So we're going to skip over the next question just for now, but we will come back to it. So don't cross it off in your book. And so, but let's talk about the question just for a second. It says, are the following figures equivalent? So if you had a question like that, are they equivalent? We would solve it the same way. We would find the areas of both. We would see if they were the same. If they are the same, they're equivalent. If they aren't, they're not. This last example is a slightly different kind of question. It says, given that the following figures are equivalent. So we're told that they are equivalent. So knowing that these two shapes are equivalent, we need to find the radius of the circle. Okay. So let's find the area of our diamond first. Area is diagonal 1 times diagonal 2 over 2. Diagonal 1, 13. Diagonal 2, 7. So it's 13 times 7 divided by 2, which is 45.5. We don't have units, so let's just write units squared. Now that we know the area of this diamond is 45.5 units squared, we know that the area of the circle also has to be 45.5 units squared, right? These two shapes are equivalent. So the area of one is the area of the other. So the area of a circle is pi r squared. We know that the area has to be 45.5 because they're equivalent. And now we'll use some algebra to solve for r. Let's divide both sides by pi. And again, I'm using the pi button on our calculator just to make sure it's a little more precise. So 45.5 divided by pi is 14.48. And then I'll take the square root of both sides. So the square root of 14.48 is 3.81. So a concluding sentence, the radius of the circle is 3.81. We don't have units, so again, it's just a u. Now, that's all I have for you for your notes for today. What I'd like you to do for the rest of class is if we go back to page 173, there's some practice questions I'd like you to work on. So I'd like you to do the practice questions on page 173 and 174. We'll skip some pages. And then I'd like you to do the practice questions on page 182 and 184. So let's get those practice questions done. Just a reminder that there is an answer key at the back of your workbook, so make sure you're double checking your work as you go. And I will see you back in class tomorrow. Have a great day.